Good morning, friends. In today's lecture, we are going to study about hydraulic pump. Pump is the heart of a hydraulic system which converts mechanical energy into hydraulic energy. In this, mechanical energy is delivered to the pump via a prime mover. In this case, we are going to use electric motor as the prime mover. Due to mechanical action, the pump creates a partial vacuum at its inlet. This permits atmospheric pressure to force the fluid through the inlet line and into the pump. The pump then pushes the fluid into the hydraulic system. This is how the hydraulic pump works. Now we'll see the classifications of pump. The pump is going to be classified into two types. One is non-positive displacement pump, other one is positive displacement pump. Which type of pumps you will call it as non-positive displacement pumps? Non-positive displacement pumps are generally used for low pressure, high volume flow application where low pressure is required and high volume is required. There we are going to use non-positive displacement. The best example for non-positive displacement is centrifugal pump, which is used to lift water from the resource to the overhead tank, which we will be using in our home or in the agriculture field, where you are going to take or you are going to transport a water from a river to the agriculture land. Because they are not capable of withstanding high pressure, this non-positive displacement will not withstand high pressure. Non-positive displacement pumps is primarily used for transporting fluid from one location to another. As I told you, here we are going to transport fluid from one location to another. The other example of non-positive displacement pump is axial propeller pump. Next is the positive displacement pump. Positive displacement pumps are used for fluid power systems. In a fluid power system, a positive displacement pump ejects a fixed amount of fluid. Here it is going to eject fixed amount of fluid into the hydraulic system per revolution of pump shaft. As the pump shaft rotates, that is per revolution, it is going to eject fixed amount of fluid. These pumps, that is positive displacement pumps, have advantages over the non-positive displacement pump. First one is it is used for high pressure capabilities. As I told you, non-positive displacement pumps are used for low pressure, whereas positive displacement pumps are used for high pressure capability. Positive displacements are small and in compact size, and it has a high volumetric efficiency. How you are going to calculate the efficiency? It is output to input, and they have great flexibility of performance, can operate over a wide range of pressure and speed. Now we'll see the different types of positive displacement pump. The positive displacement pumps are gear pumps. In that, two types are there: external gear pump, internal gear pump. The second one is vane pumps. In that, balanced vane pump is there, unbalanced vane pump is there. The next one is piston pumps. In that, axial type is there and radial type is there. Now now we will study about the centrifugal pump. The centrifugal pump is also called as impeller pump. Before we start discussing, or before we start studying about the working of a centrifugal pump, we should know the different parts of centrifugal pump. The first one is a impeller. This is a impeller. Impeller is the rotating part of the pump. It is a wheel provided with a series of backward curved blades called as vanes. These are called as backward curved blades called vanes. It is mounted on a shaft. This is mounted on a shaft which is connected to the shaft of the electric motor. The second one is the casing. This is the casing. A casing is an airtight chamber surrounding the impeller. Surrounding the impeller, it is designed with its cross section gradually increasing. Here you can see that the cross section is gradually increasing so that the velocity of flow decreases, resulting in an increase in pressure of the fluid. As the velocity of water decreases, the pressure of the water increases. That's why the cross section is gradually increasing. Next one is a suction pipe. This is the suction pipe. Suction pipe is a circular pipe with its upper end connected to the center of the impeller, which is known as eye of the impeller. This is eye of impeller. The lower end of the suction pipe is immersed in the suction. The lower end is immersed in the suction. The suction pipe is fitted with footwall and a strainer. The strainer avoids the entry of any foreign material into the suction pipe, while the footwall is a non-return or one-way valve. This is called as one-way or non-return valve that opens only in the upward direction. It will open only in the upward direction so as to prevent the suction pipe draining out when the pump stops. When the pump stop working, it will prevent it from draining out. The next one is a delivery pipe. This is the delivery pipe. A delivery pipe's lower end is connected to the outlet of pump, while the upper end is connected to the tank. These are the different parts which are going to be used in centrifugal pump. Now we'll see how the centrifugal pump work. As the electric motor starts rotating, this shaft is connected to the electric motor. As the electric motor starts rotating, it also rotates the impeller. The impeller also starts rotating. The rotation of the impeller creates suction at the suction pipe. As it starts rotating, it is going to create a suction in the suction pipe. The rotation of the impeller creates suction at the suction pipe. Due to the suction created, the water from the sump or the reservoir starts flowing into the casing through the eye of the impeller. The centrifugal force created by the rotating impeller. As the impeller starts rotating, it creates the centrifugal force. Acts on the water. That centrifugal force acts on the water, causing it to flow radially outward and towards the outlet of the casing. As the centrifugal force is created, the water moves radially out and towards the outlet of the casing. Since the impeller is rotating at high velocity, it also rotates the water around it in a casing. The area of the casing increases gradually. Here the cross sectional area increases gradually in the direction of rotation. This is the direction of rotation. So the velocity of the water keeps decreasing. As the cross sectional area increases, the velocity decreases and the pressure increases. At the outlet of the pump, the pressure will be maximum. At this particular point, the pressure will be maximum. Now from the outlet of the pump, the water flows to its desired location. The desired locations might be over a tank, or if you take example of agriculture field, it will the water will go to the delivered location through the delivery pipe. This is how the centrifugal pump works. The notes related to this topic is given in the description. You can download those.